Tell me, what is mean by half adder? Yes, tell me what is mean by half adder.
It is a device which is used to add two devices. Two components.
It is the circuit which is used to add two bits. Okay, so if we have the input two input bits, that is suppose A and B, then half adder adds these two bits and gives the result in terms of sum and carry. Okay, so that means we are getting a result with in two bits. That is the sum. One is the sum, that is the addition of that two bits, and then carry, which is generated after addition of these two bits. Okay. So that means how many input ports are there for half adder?
Two input ports, A and B.
Two input ports, that is the A and B, and output ports. Okay. So another
Again, it
okay, Prajakta, wait. Others will respond now. Okay. So Megha,
Yes, ma'am.
yes, what is the answer? So tell me what is my question.
इनपुट पोर्ट कोणते?
Separate input port.
A and B.
A and B are the input ports, and then Utkarsha, how many output ports are there?
Two.
Two output ports. Okay, that is the name that output port.
Sum and carry.
Sum and carry. Okay. So let us start with the VHDL program for this half adder. Okay. So what is the procedure that we need to follow for VHDL program? Write VHDL program in Xylem file. Tell me the procedure. What we have to do? How to start? Pratiksha? तर मला प्रोग्राम जर लिहायचा आहे तर मला काय करायला लागेल?
Library declaration.
Okay, but before that, in a VHDL, that is a Italian science, what I need to do? I need to have a project. Okay, so if I am going to write this program in the earlier project only, then I can use open project in a file menu. But as I want to have a new project, so I will click on new project. Okay. Give the name to this. So I'll give this name to this as a experiment 1, and then as this is a part, okay, and then okay, then just give A 1. Okay. Then here, what is this window? These are the project settings. Okay, will give us what idea about which family that we are going to select for FPGA, then which device, and all the things that's related with the FPGA that we are going to select here. Okay. So we have selected Spartan 3E family, then XEA 3S 500E device and V200 package. Okay. So click on the next here, and then you will get the summary. Whatever you have set uh, you have decided for the settings for that project, it will be there in the summary. Click on it. So what you will observe, whatever project that you have created, that will be present in this hierarchy window. Okay. So right click on that and click on new source, and then click on, as we want to write VHDL model, so click on VHDL model and give the name to the file. One, next one, and then next. So what is this window? This is the window that is going to give us entity of that program. Okay, but I'll keep this part or mentioning port names here. I'll go to the next part. So here you will get the skeleton of the VHDL program. So the summary, that is the company name, module name, and all that things, it will be there. So these are commented in a commented form. So let us go to the program. So what is this part now? Rishikesh? What is this? Kaustubh? Ajay? Nitin? Those who have not answered, I am going to put action mark for them. So Rishikesh, Kaustubh, Ajay,
Yes, ma'am.
are you there in the meeting or not?
Yes, ma'am. Ajay.
Ajay. Okay, so what is my question? अरे पटपट बोला. ऐकायला येत आहे ना?
Yes, ma'am.
हा बोला ना मग. माहितीच नाही असं आहे का? How many times we have used xylene diacetyl? Okay, who knows the answer? Harshal?
Yes, madam.
Yes. What is this?
Question काय आहे?
What is this part?
Library declaration.
Library declaration. Why we are doing this library declaration?
Program setting आहे.
Yes, in program we need to add certain library so that we can add inbuilt प्रोग्राम
फंक्शन असतात मॅडम त्यात फंक्शन.
पॅकेजेस मध्ये फंक्शन्स असतात. ओके, सो there we are adding a library. Okay, now after that, what are the different units of VHDL program? What are the different units? One is the library declaration part, then entity declaration and architecture. These are the three units. So here, uh, library declaration. Then after that, entity. We need to write a entity. So now for half adder, we have uh, given the name to this entity as a ex1 underscore a. Okay. So now tell me what will be there in an entity. Jayesh, Gopal,
Yes,
Yogesh,
ma'am.
Yogesh.
Yes, ma'am.
Yes. So tell me what will be the entity for half adder. What will be the statements here now? तुम्ही प्रोग्राम सांगायचे मला, आता मी टाईप करणार आहे तर त्याच्याप्रमाणे. तर हाफ ॲडर साठी आपण एक्सपेरिमेंट करतोय, तर हाफ ॲडरचा प्रोग्राम सांगा मला. एंटिटी मध्ये काय असणार आहे? व्हॉट इज द सिंटॅक्स? गिरीधर,
Port A in HTTP logic.
yes,
इनपुट पोर्ट.
input port. Okay, so input and output ports that we need to declare in a entity. What is mean by entity? What is, why we are using entity or what it specifies? हे माझा क्वेश्चन वेगवेगळ्या पद्धतीने विचारलाय की what entity specifies. Okay, so this is the question. Entity gives idea about the input and output pin of that system. Okay, so here we need to specify ports. Okay, so tell me the statements now. तुम्हाला प्रोग्राम लिहायचा आहे असं कन्सिडर करून तुमच्या नोटबुक मध्ये तुम्ही लिहिता तसं मला सांगा. मी टाईप करणार आहे आणि त्यानंतर आपण तो एक्झिक्यूट करायचा. इट इज अ व्हेरी सिंपल प्रोग्राम. डोंट वेस्ट दिस मच टाइम. आपण इतक्या वेळा केलाय हा प्रोग्राम. श्वेता, वैष्णवी,
Ma'am, port in bracket A and B in bit and sum and carry out bit.
port A,
A,
B.
comma B in bit.
Okay, so before that we should be in. Okay. Now instead of using bit, yes, so as I told yesterday
STD.
that data type that we can have as a bit and then std underscore, yes, std underscore logic. Okay, so we are going to use std underscore logic because it is preferable to use that as it has 9 different values. Okay? will use std underscore. Okay. Then after that, yes, what will be the next statement? Okay, all things that you need to tell me.
Some comma carry.
Okay, so shall I go to the next slide?
Semicolon now. A and B in std underscore logic. Semicolon.
Okay.
After that, sum and carry. Colon. Std underscore logic. Bracket complete and semicolon.
Okay, is this correct?
Ma'am, out of the
Out.
Right, sir.
So that means we have here two ports, input ports A and B, and two output ports, sum and carry. Okay. So we have, this much is the entity of for this half adder. Okay. Then after that we need to write the architecture. So what will be the statement here? Architecture. How we write architecture? We need to use a keyword, that is architecture. Then give the name to that architecture, and then keyword of, and then entity name will be there for which we are writing this architecture, followed by each keyword. Okay. Then if there is any declarative part in architecture body, so that we need to specify, and then begin with the statements that we want to execute. So is there any declarative part in this code?
no, ma'am.
Okay. So let us start in this. Okay. So now tell me code is there.
Sum
Whatever
equal
is
to
sum,
Sum less than is equal to A XOR B.
A, XOR B,
Semicolon.
hmm,
Carry less than is equal to A and B. Semicolon.
and B.
Next line. And adder plus architecture.
Hmm. Yes.
झालं ma'am.
Okay. So let us save this. Okay. Synthesize this. So let us take syntax. Okay. View RTL schematic also. So here you can see the schematic. So outside here you can see the input pins as well as output pins. Okay. So that is the RTL schematic for this half adder. So here you can see again. Okay. Okay. So output carry and output sum that you can find. Now here till now we have written the code for this half adder. But what is the next step? To simulate this program and view the time waveforms for this. Whether our code is giving actually a correct result or not. For that, what we need to do? We need to write a test bench code. So for test bench, what we need to do? We have to add a new source to the same program, a source project, and select VHDL test bench. Now tell me what are the changes that I need to do. So, what is there in this first here? There is a library declaration part as usual. How we write in a VHDL code. Then after that there is the entity, and after that there is the architecture. But you can see here there is no any code declaration part in this entity, but just only started with the entity and then ended. But code declaration is not there. In the architecture, you can see that before actually starting with the architecture body, here there is certain declaration. So we have instantiated components that is half ex1 underscore a in this code. Okay. And for that, whatever are the codes that we have mentioned here. Okay. So this automatically generates, this program automatically generates whenever you are associating your VHDL code with the test bench. Okay. So that time, all that parts that will be there. Okay. So what changes we need to do here to add stimulus? काय करावं लागेल इथे आता आपल्याला changes? Whether we are going to use clock in this circuit? Are we going to use clock? Just answer your roll call. Roll number 1.
Yes, ma'am.
2,
Yes, ma'am.
3,
Present.
4,
Present, ma'am.
5,
Present.
6,
Present.
7,
Present.
8,
Present.
9, 9, 10,
Present.
11,
Present.
12,
Present.
13,
Present.
14,
Present, ma'am.
15,
Present.
16,
Present.
17, 17, 18,
Present.
19, 19, 19 is there. 20,
Present.
21,
Yes, ma'am.
22,
Present.
23,
Present.
24,
Present, ma'am.
25,
Present.
26,
Present.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Present, ma'am.
30, 30, 31, 31,
Present.
32,
Present, ma'am.
33,
Present, ma'am.
34, 34, 35,
Present.
36,
Present, ma'am.
37, 38,
Present.
39,
Present.
40, 40, 41,
Present.
42,
Present.
43, 43, 44,
Present.
45, 46,
Present.
47,
Present.
48,
Present.
49,
Present, ma'am.
50,
Present, ma'am.
51, 52,
Yes, madam.
53,
Yes, madam.
54, 55, 56,
Present.
56,
Present.
57,
Yes, ma'am.
58,
Present.
59,
Present.
60,
Present.
61,
Present, ma'am.
62, 63,
Yes, ma'am.
64, 64, 65,
Present.
66, 67,
Present, ma'am.
68, 69.
Yes, ma'am.
Okay. So now tell me about this segment code. So actually here we have instantiated components. So we have declared component that we are going to use in this code. Okay. After that we have declared what will be the initial value of the signal A and B. So initial value that will be 0 and that we have mentioned here. That we are going to use A and B as a signal, and also sum and carry that also will be there as a signal, but we have not mentioned the initial value. After that, by default, this statement will be there, that is a constant clock period and then timing is 10 nanoseconds. But actually, we are not going to use clock in this, so we are going to comment it. So clock will be a comment. Then after that, this architecture will begin, and there we are going to instantiate whatever is the unit under test. So unit under test, that is nothing but a ex1 underscore a, that means whatever is the program that we have written earlier. Okay, and then we are going to map all the ports of that with the component port. Okay, so here we are going to map that all that ports, and then after that there is a clock switch. Okay, but as we are not going to use clock, so we will delete that, and then there is a simulation. Similar process. So in a similar process, we are going to give in certain inputs to A and B, and depending on that, we are going to check what are the outputs. Okay, so what is the output there? So let us give certain inputs there. So A, we are going to assign certain values. I'll give these two combinations only. That means A is equal to 1, B is equal to 1, and A is equal to 0, B is equal to 1. So for A equal to 1 and B equal to 1, what should be your result? Sum should be equal to what should be your result?
Ma'am, both when 1 then sum is equal to 0 and carry is equal to 1.
Okay. And for A equal to 0 and B is equal to 1,
Sum is equal to 1 and carry is equal to 0.
okay. So shall I save this code now?
मॅम A is equal to मॅम ते कोड्स चेंज झालेत वरचे.
So you can see that there are so many errors in this, 3 errors, okay, in this. So let us check what are that errors. So what is the error here? This code should be double quote.
Single quote ma'am.
So it should be single quote. When we give a double quote, double
More
quote कधी
than
use
one
करायचं?
more than one number असेल तर किंवा कॅरेक्टर.
मल्टीबिट नंबर असेल तर आपण काय करतो? डबल कोट. हे आता इथे सिंगल बिट आहे. सो हियर इट शुड बी अ सिंगल कोट. Okay, now is it correct? Still there is error at this line and this. So what is the error? Satyajit, what is the error in this code?
Semicolon.
Yes, semicolon. That is remaining. Yeah. So okay, still there is a error. Now tell me what is that? What is the error in this code now? Actually, it is showing error at this line, but the error is at this statement. Okay. So this is the hint. Now tell me what is error.
Semicolon ma'am.
Okay. So I'll give you a semicolon. Okay. So that was remaining. So each and every statement in a VHDL that should be ended with semicolon. Okay. So whatever is the statement that we are having in the program, that should be ended with semicolon. Simulation. Okay. So it has been completed successfully. Now take for the go for simulate behavioral model. So whatever is the model we have, we are going to simulate. Zoom in. When both are 1 1, sum is 0 and carry is 1. When A is 0 and B is 1, sum is 1 and carry is 0. So we are getting the result, correct result here. So that is the half adder. Okay. So we have to actually complete full adder and 4-bit full adder, but as we have no time now, so you have to write VHDL code for full adder and 4-bit full adder as a homework. Okay, so this is your homework for today. Okay, so write a VHDL code for full adder and half adder.
मॅम तुम्हाला शेअर करू दे ना की उद्या क्लासमध्ये सांगायचं.
हा उद्या क्लासमध्ये ऍक्च्युली उद्यापासून क्लासेस नाही आहे तर शेअर केला तरी चालेल.
ओके मॅम चालेल.
Okay, ठीक आहे. So for today we will stop here. So you have to complete your homework today itself.